Welcome back, Physics 30. This is Unit 1, Part C, Distance and Displacement, and it refers to pages 41 to 50 of the duotang. And the objectives for this lesson are to look at position, reference point, number line, displacement, equivalent displacement, distance, and negative vector. And the big thing here is to distinguish among position, displacement, and distance. Specify position on number line. Look at equivalent displacement vectors. Represent vectors on scale diagrams. We likely won't be doing much of that because we have done a lot of that already. So we'll be looking at the component method again, and then solving problems related to position, displacement, and distance. So first of all, distance is a measure of the total length without direction. And it looks at all steps taken. So if you take the long way home, for example, you would measure every step of that long way home, even though as the crow flies it would be a shorter distance. So all steps taken during a trip. Distance is a scalar quantity because if we're just simply looking at all the steps, we're not concerned about direction. The symbol used is just a d. So that is all distance. It's a vector, just use a d. Position is what we've been doing already with the resultant vectors, the location of an object relative to the starting point or reference point. So it is a vector quantity because you will need a direction to say how far and in what direction you are from your starting point. And as we've seen, the symbol for that needs a half arrow over top of it, implying that it's a vector. So d with the vector half arrow over top of it. And lastly, displacement is the change in position. If you have a position in one area and a change in position in another area, the change in position from one to the other is referred to as displacement. So it is also a vector quantity, and we use the symbol delta d. So the triangle here is actually the Greek symbol delta, which implies change in. So change in displacement is really going from one position to another position. And if we look here, how does displacement differ from position? Position has a reference point and displacement does not. Displacement is just the change between 2 points taken. Okay. I drew a number line on the top of this page because it'll help you with number 6, so you may wish to do that as well. Can equivalent displacements have different starting points? Yes. So for example, if you said you were 2 kilometers east of the Cornwall and 2 kilometers east of Martin Collegiate, they would have different positions, but they would have the same displacement. So from the Cornwall Center to a position 2 kilometers east of that movement is the same as 2 kilometers east of anywhere, but of course, different positions. Okay, so number 6 deals with having 2 positions here and looking for what is the displacement. So the change in displacement. A position of -4 to a position of +5, what's the displacement? So if you look at the number line, from starting at -4, going to +5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be +9. Going from a -4 to a -9, -4 to a -9 over here, 1, 2, 3, 4, 5, and we're going in the negative position, so of course -5. So see if you can do actually I'll do the next two here. +5 to +11, so starting at the 5, going to the 11, it's +6. Now this one here is kind of tricky because you're going from +3 to -5 to +7. So +3 to -5 to +7. You started off at +3. You did this movement, but when all is said and done, you ended at +7. So it's just like the vector drawings we were doing. Start, finish. You're only concerned about start to finish. So that's going to be +4 kilometers. Okay, I'll give you a chance to finish off these last 3. Maybe pause the video, then come back and see how you made out. Okay, if you had a chance to do this, going from +8 to -8. So positive 8 to negative 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in the negative direction. So negative 16 clicks. F is similar to D, went from positive 2 to negative 3 to positive 3. You started here, you did this, you ended up here. So in the grand scheme of things, start to finish is only positive 1. Because you started at 2, went to negative 3, but ended up at 3. So we're only concerned about difference from final and initial. And lastly, you're going from a position 23 kilometers west of some area to 2 kilometers west of some area, so that's 21 east. You're going from far west, moving to the 2 kilometer west position. Okay, so easy. If you have a number line there, you can just visualize it and work it. Just be careful, because if you try to do it algebraically, you may miss areas, especially around 0, where it gets a little tricky. Distance. So distance is simply every step you take without a direction. So in the part D and F, you're gonna take every step into account. So a lot of these are gonna have the same magnitude. For example, negative 4 to positive 5, 9 kilometers from B. Negative 4 to negative 9, that's still going to be 5 kilometers. 5 to 11, that's still going to be 6. From positive 8 to negative 8, where am I at here? C. Okay, D. So here, positive 5 to negative 5 to positive 7. Let's look at that one. So starting at 3, 1, 2, 3, 4, 5, 6, 7, 8. Turn around. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Were we going to 8? Sorry, we were going to positive 7. So 20 kilometers. Look at how I turned around there. You have to consider every step. E, positive 8 to negative 8, still a movement of 16. F, 2 to negative 3 to positive 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it should be a movement of 11. There it is. And then lastly, it's very similar, 21 kilometers east. Okay, so displacement and distance traveled on a number line. Okay, I'll maybe make a part 2 to this segment, go over number 8, and then I'll go over the vocab there. So that'll all be in part 2. So see you shortly.